All right, ionic bonding. This is what you guys learned in class last time. Ionic bonds are from when you have metals, nonmetals, and electron transfer. Don't forget that these guys up here are not atoms. They are ions. Ions are atoms that have lost or gained electrons and therefore have a charge. Don't forget, only opposite charges attract one another, not like charges. Like charges push each other away. So positive and negative are opposite. They attract one another. The negative means that it has more electrons near it. This is a cloud picture to the right that's illustrating that most of the electrons are being pulled towards chlorine, which makes sense because chlorine is more electronegative. It wants electrons to look like a noble gas. So, what is it exactly that's different between ionic versus covalent? Ionic is metal and nonmetal, and then the ions just start sticking together in a repeating pattern. On the left here we see that it is 1 to 1, 1 to 1, 1 to 1 to 1 to 1. On the right, it's still 1 to 1, but see how they're all separate? That's the difference between a molecule and an ionic compound. Ionic compounds are crystalline because they all start sticking together in a repeating pattern. Molecules are not. They're discrete, separate molecules from one another. So, let's talk about the stupid comic that I had in the very beginning of the slides. The comic strip that I showed in the beginning is illustrating this concept of opposite charge. It says perhaps one of you gentlemen would mind telling me just what it is outside the window that is so attractive. Obviously, the guys are like, ooh, and they're being pulled towards the negative ladies. All right, so ionic compounds is really a mouthful. We call them salts because they look like salts. They're a crystalline structure of repeating pattern ions. Sodium, chlorine, the charges balance each other out in a 1-to-1 ratio because the charges balance each other out. Positive 1 and negative 1 gives you a neutral charge. The ions will stick together to form a neutral charge, always. This fancy name that we have for when they stick together and form this crystal structure is actually called a crystal lattice structure. We use the word lattice because it's just like a fence lattice. That looks like this on the right. So there is such a thing as lattice energy. You're not going to be required to really understand lattice energy until you get to AP chemistry, but I want to introduce it here. It's energy released or absorbed when anions and cations come together to form a crystalline structure. Believe it or not, when you dissolve some salts, they break apart the ions, and when that happens, energy is released. That's why when you mix some salt and water, it either raises the temperature of the water or drops the temperature of the water. So we would do that, but it's not worthy right now. Now here's some properties of ionic compounds that I know you learned in 8th grade. Ionic compound salts have the strongest bonds. We know it because it takes the most amount of energy to cause them to start to melt. They have a high melting point. That's, of course, the point needed to break the bonds. They're also hard and brittle. Just think salt. You have salt grinders. You know, it's a crystal that you grind up. They're brittle and hard at the same time. They dissolve in water and can conduct electricity. When on the left, on this glass that you're looking at right here, you see the salt has broken apart and you have all these ions in your solution. Whenever you have ions in solution, it's called an electrolytic solution, an electrolyte solution. You've probably heard, the ads for Gatorade having electrolytes. That's really a fancy way of just saying it has salt. Why is salt good for you? Well, electricity can travel through salt. Why would electricity traveling through your body be good? Well, if you're exercising and you're drinking Gatorade, it's probably good for you because it's going to allow electrons and ions to flow in your body because you need electrons to cause the signals for your muscles to contract. So it's very much necessary to have those ionic solutions in your body. Sugar water doesn't conduct electricity. You could jump into a bathtub full of sugar water, drop a toaster in it, and not die. You'd be fine. Moving on. Ionization energy actually explains a lot about how ions literally lose or gain electrons. Ionization energy is the amount of energy required to remove, not add, an electron from an atom. So it's how much energy it takes to cause this little guy on the outside of hydrogen to be lost, and now I have this charged ion, which is hydrogen. The higher the energy level of the electron, the easier it is to remove. What this means is that the guys in the bottom left of the periodic table, they're big atoms. They like to lose electrons to look like noble gases, and it's really easy for them to lose an electron. So that means that they have a lower ionization energy. The guys that want to gain electrons in the top right of the periodic table to look like noble gases, they want to gain electrons, so it takes a lot of energy to force them to remove an electron. So the ionization energy trend is it increases to the top right. A classic example of why this is helpful to know is because group 1 forms positive 1 charges. All of these alkali metals like to lose their outermost valence electron because they only have one. Remember, we drew Na with a dot and said that what does it take to lose them, or what does it take to look like a noble gas? And we said, oh, it just has to lose that electron, and then it looks like a noble gas. When you lose electrons, you have a positive charge. So group 1 is positive 1. Group 2, class, could you identify the trend? What charge in positive would be group 2?
+2.
Period 3, represent group 2. What charge?
+2.
Thank you, a little bit better. Positive 2. Metal, not easy to explain. Weird things happen in the d orbitals, as you found out on your modern atomic theory test. We'll address that later. Now when we get over here, let's look at nitrogen. Nitrogen wants to be neon. It looks like it needs to gain 1, 2, 3. So that means it wants to gain electrons, so it's going to form a negative charge. It's going to form a negative charge. Class, what charge is it going to form? Negative 3 charge. How about oxygen, sulfur, and selenium?
-2.
Good. How about fluorine, chlorine, bromine, iodine?
-1.
Good. How about noble gases?
0.
Yay! You
We
get
win.
what you learned previously about ions being formed on the periodic table. These are the trends. This is what I wanted you guys to draw on your periodic table, that metals typically lose electrons to form a positive charge. Nonmetals typically gain electrons to form the negative charge, and that's to look like noble gases. Each element does this, and when they do it, they form what's called the octet rule. They get 8 electrons around it because all noble gases, helium, neon, argon, krypton, xenon, actually I should say except for helium, they all have 8 valence electrons. Helium has 2, and that's why I wrote down everyone wants 8 or 2 valence electrons to be stable. These metal guys, all from here to here is unknown, and that's the one new thing you need to learn today. The one new thing is that the middle of the periodic table has different charges depending on their mood. They're moody elements. We have a way to figure it out. There's a common ion chart that's on your web that helps you identify which ones they are. Let's talk about sizes of elements. This will help you on the questions at the end of the ionic bond worksheet, which you need to finish because it's going to be due. When you are a nonmetal, you like to gain an electron. It's represented by this green sphere on the left. When you gain an electron, it's like gaining weight. Although electrons weigh nothing, but you get bigger because you're putting it further away from the center of your nucleus. So when you gain that electron, you get larger. Metals lose an electron. If you lose electrons, you get smaller. So metals always lose electrons and form what are called cations, positively charged ions. How do you know cation means positive? Cation has a T in it. Oh my goodness, that T looks like a plus. That's going to help you remember that cations are positively charged. Electronegativity is a measurement of how much an atom attracts electrons. The guys in the top right-hand corner of the periodic table, they want electrons really bad because they're really close to looking like a noble gas. They only need 1 or 2 more, and they're looking like a noble gas. So they pull on electrons really strong. So this nonmetal likes to gain electrons to look like a noble gas, so it has a strong pull on electrons and steals one away from the metal. And that's why metals lose, and that's why nonmetals gain. And then you end up with a nonmetal with a negative charge and a metal with a positive charge. We use Lewis dots, which are valence electrons that we draw around the center of an atom, to represent how many valence electrons there are. They always want to have 8. So my potassium can either gain 7 or lose 1. It's obviously going to do the easier. It's a metal. It's going to lose 1. Chlorine needs just 1 more, so it's going to gain 1. So what happens is potassium loses its electron to chlorine, forms a positive charge, chlorine has a negative charge, and then those opposite charges attract one another. Now, what happens if you're dealing with sodium and sulfur? Sulfur needs 2, but sodium can only provide 1. Darn it. So you need 2 sodiums to balance out the charge of 1 sulfur. So if we were going to write out the formula for this compound, it would be the ratio of them sticking together in that crystal salt lattice structure would be Na2S. That's the end of my presentation. If you guys have further questions, please let me know.